the work done by this one, which is, sorry, plus the work, but is minus the force 2 times dl2. Why I put negative? It's in the negative direction. In addition to that, what other things is doing work? Gravity is doing work, right? When it's moving upward, the work done by the gravity is positive or negative? Negative. So we can say also that this will be negative mg delta h, mg h2 minus h1. And the network, what is equal to? What is the network equal to? The change in kinetic energy. The change in kinetic energy. This is the work energy theorem. So I can say that F1 dl1 minus F2 dl2 minus, instead of mass, I will put that in form or in terms of rho, because it's a fluid. Since it's a fluid, I can say that this will be rho times gravity times H2 minus H1 equal, what is this? The change in kinetic energy. What is the kinetic energy final? At the second place, assuming that the fluid is going from here to here, what is the positive kinetic energy? 1/2 mv squared, but I will use rho. So rho, right, times what? The change in volume here. Rho times the volume times B2 squared minus B1 squared. Is that right? This is the mass times the volume. Is the m, but remember, it's the same dm here than the dm going out. So I can just factor out rho times dB, B2 minus B1. What I will do now, I will put everything that has 1 to one side and 2 to the other side. So I have F1 dl1, but what is F in terms of pressure and area? What is F in terms of pressure and area? Because when we are talking about fluid, we don't talk in terms of force, we talk in terms of pressure. What is the force in terms of pressure?
Pressure times area.
Pressure times area. So pressure 1 times dl1 times area 1 times dl1. Plus, I will just leave here everything that has 1 and 2 to the other side. So I have this. Then I have minus minus. Can you see? The 1. Minus and minus. So I can say plus rho g h1. And this that is minus here, I will move to this side, which will be plus 1/2 rho dB V1. This is the volume. This is V1 squared. And this will be equal to the same to the other side. What will have to the other side? I will move F2 dl2 to the other side as pressure times area, but to the other side. So I will have pressure 2 times area 2 times dl2. This is this. Plus, I will move this to this side as well. Rho g h2 plus 1/2 rho dB V2 squared. So I move everything that has 1 to one side and 2 to the other side. And now what happened? What is area times the distance or the length? The volume, which is dB. But remember, dB is the same there than here. The flow rate is the same. So this ADL, here I missed something, rho.
There's supposed to be a V, right?
Yes, I didn't have delta V, but it's rho delta V or dB here. Rho dB. I substitute the mass. So here has to be rho dB. So ADL dB, dB, ADL. And here I have to have also rho dB. GH2, dB cancels out. And dB cancels out. So every dB cancels out, and ADL is the same than dB. So now I can say, and this is what will be the Bernoulli's equation, that the pressure will be due to 3 factors rather than 2. So here I have that the pressure is due to 2 factors. External pressure, rho GH. I have here 3 factors. P external plus rho GH plus what? Plus 1/2 rho V1, the velocity 1 squared. On the other side, I will have P2 plus rho GH2 plus 1/2 rho V2 squared. Now, we can see that the Bernoulli's principle is an extension of the Pascal principle. Sorry. Can you see that? So what is missing here? Pressure A is equal to pressure B. So what is missing here? Of those 3 terms that I have in the Bernoulli's equation, what is missing? 1/2